stage is yours.
Thank you very much. Hi, everybody. Let me introduce you, Peter, and me. My name is Miro. We both work at Red Hat in Python maintenance team, and we take care of the Python ecosystem in Fedora. We package not only the Python interpreter, but also various Python packages, and we build the tools that allow that to happen. I'll give the word to Peter now.
Right. Hello. I hope you can all hear me. So I will talk a bit about integrating a language ecosystem in a distro. The language ecosystem, of course, is Python, but I hope you can generalize this to any other package ecosystem you have to take care of. And our distro, as you know, is Fedora, but I really hope any other distros can take these ideas and run with them and adapt it to themselves. I'll not do the generalization here. I leave that up to you because I don't know all these other systems, but hopefully it'll help. So this word integrating, that's very important. And I would say as distro packagers, that is what we do. We integrate software into a cohesive whole. We take the pieces that developers build and publish somewhere on the internet, and we make it all work together. Specifically, we adapt the software to the distribution, which has its own rules how to do everything, and we adapt it to work with all the other parts. We run the test suite, we run additional checks and ensure that everything works together. We handle user reports. Hopefully users will report to us, and we can then, if we find some issues in the upstream project, we can forward the report to the developers. We also want to provide long-term maintenance, so we can take care of projects even after the developers have moved on to something else. If some users want an older version of a project, then we can take care of that and guide the users to upgrade more smoothly than they could otherwise. Of course, Fedora is a volunteer-driven project, so these are goals and not guarantees, but there are paid distros where you do have those guarantees and contracts. Now, specifically, how we do this is we curate metadata, we provide consistent naming, consistent versioning, some descriptions, all the stuff about projects. We do licensing checks, which are pretty important so that our users know they can actually use the software or modify it. And we specify how the software is built. So we define the dependencies, we write some build scripts so that everybody can take our packages and rebuild them on their own, and so that our tools can build them automatically. So all of this goes for any distro packager, but we too specialize in integrating Python. And where Python packages are published upstream is the Python package index, or PyPI. We've had some talks about it already. And this is also a collection of packages. It would seem that it's similar to a distro, but there are very important differences between the two. PyPI is free for all. Anybody can publish their package there. They just have to find a name that's not used yet. And PyPI is designed to make it simple for the developers to publish their package. On the other hand, a distro is integrated. It's not as easy to put a package in a distro. Everything should work together. There are extra things to look out for. There are extra checks to run. The package set is curated, but it is simpler for the users. If you want to install something, it's arguably easier to use the distro package than to go for PyPI. Another difference An obvious one is that PyPI covers only one language ecosystem. If there is some dependency that's not written in Python, then you either write in a README that you need it and people install it by hand, or you vendor it and include it in your package, which has its own set of problems. A distro, on the other hand, includes all the software that can exist, and cross-distro or cross ecosystem dependencies are a normal thing. Also, the packaging tools in a distro have been around for longer, and there are some things that the PyPI or the ecosystem-specific marketplaces are still kind of lacking, or that have been added only recently. Things like weak dependencies, proper dependency solving, license information, or ensuring that the builds correspond to the source. There are also auditing tools and processes, for example, for handing over packages once they're not maintained anymore. All these things are generally more mature in a distro. There are some downsides to distro. Obviously, PyPI is cross-platform. A distro is a platform, so if you're on Windows, you can't use Fedora, but you can use PyPI. More interesting difference is that PyPI is designed to install packages into all kinds of different environments. You usually have virtual environments. You have several of them on your system, and from PyPI, you can either install system-wide, although that's not really the use case for it, or you can isolate your installations. In a distro, usually you install something system-wide. There's only one version of anything. That's not a hard rule, but it's pretty hard to break it. To summarize, I think the main difference is that PyPI is built for developers. It makes it easy to get your software out or to use libraries that somebody else built. But a distro is targeted for users. It makes it harder for the developers and the maintainers, but easier to actually use the software itself. So I think it is worth our time to take packages and rebuild them as RPMs. So this is what we do. We integrate software into a cohesive whole. Really, the day-to-day work is that we take stuff from PyPI and rebuild it as RPMs. It's not as easy as that, but that's what we do. Now, there have been some other talks about the Python packaging tools. TC talked a bit about the history, how there was a single tool, setup tools that did everything from downloading, installation, dependency solving, everything like that, to the state or the goal that we have now, where there are multiple interoperable tools and standards that make the tools talk to each other nicely. This is nice because setup tools isn't a very nice tool to work with or maintain. So the parts that setup tools did are now done by specialized projects. Each one does just one thing, but obviously does it, or hopefully does it better. And this chaotic mess that led to the creation of this platypus mascot is hopefully evolving into a friendly and clear ecosystem of interoperable tools. And one of these tools, called PyProject RPM macros, is the thing that we're building, and this allows RPM build to understand the Python-specific standards and to create distro packages, RPMs, out of standard Python projects. Now, this isn't as easy as it may sound. So traditionally, in an RPM distro, a Python project or packaging a Python project meant that you would look at the metadata that the upstream published and somehow transcribe it into what's called a spec file, or another copy of all the metadata, all the dependencies. You would basically write everything in a different format. There were tools to help with this. There still are, but because there were no standards, they often relied on guesswork, and they didn't age well, and they needed lots of hand-holding. Now that everything's standardized, we can create RPMs from Python project files automatically, or at least that would be the goal. So instead of curating the metadata, we just take it from the upstream project. Instead of finding out the license, we just look at the appropriate field in the standard manifest. Instead of the dependencies in build scripts, we just build it as we normally would. And all of this we take from the upstream project. So all of this is handled in the same way as code itself. We just adapt it to the distribution. There's no difference between a function or a dependency list. If we need to make any changes, we can patch it. If the change is useful for upstream as well, or is useful for other users, then we present the patch to the upstream project, and hopefully the developers can work with it and integrate it. This is better, obviously, because everybody can benefit from that. So we've been reporting and fixing lots of issues like packages depending on non-standard implementation details, which were usually mistakes, or undeclared dependencies, because everybody has setup tools installed, obviously. There were some declarations of test dependencies which were very hard to reuse, so we're hoping to make that clear and make that more reusable for everyone, and so on. So to make all of this possible, we obviously need to automatically convert the Python metadata to the RPM metadata. This is not as easy as it may seem, because one thing we do is, because we have a larger ecosystem, we need to mark packages as being Python specific. So there's the Fedora name of a package has a Python prefix. If we have a package that already has a Python prefix on PyPI, then we don't add that prefix. This is a nice rule. It makes some nice looking names. But then we have a package like Bugzilla, we prefix that. Then on PyPI, we have a package called Python Bugzilla, and now there's a conflict. So what do? We need to rename one of those and break the rules somehow. There are other edge cases like tools which where the users don't really care if they're written in Python, so we don't add the Python prefix for that traditionally. And all of this is such a mess that we decided that the Fedora names are basically arbitrary, and we use a feature of RPM called virtual dependencies, which is basically another name for a package. So we take the name from PyPI and we decorate it in this way, and then all the automated tools use this decorated name, and they can be sure that they are actually using the package that's named requests on PyPI. There's a bit of a problem with this, because now decisions made at the PyPI level, like who takes care of abandoned packages and things like that, are now decided for Fedora. So Fedora is losing some of its sovereignty. It hands over the decisions to PyPI in some level, but we can't really get around that, because if a Python programmer says they need requests, they need the package called requests on PyPI. So we are using the PyPI namespace, and we have to live with that, basically. Now, this is names. Once we get over names, we have version specifications. Like you need package foo greater than 1.4. That is nice and easy, but the versioning semantics are different between PyPI and RPM. For example, PyPI ignores, or Python packaging ignores trailing zeros, so we have to strip them for RPMs. The pre and post releases are marked up differently, so in order for them to compare the same way, we need to add weird symbols. The same thing for betas. If the version actually depends on the operator you are using, because in order for 1.4 to not install the 1.4 betas, as is done with pip, we need to add some special symbols so that RPM works the same way. And then, of course, PyPI or Python has special versioning operators that work with semantic versioning, and this has to be worked around with some syntax that RPM only added recently. But I think this is about the worst case you can get, and hopefully we're at the end of this tunnel. We are still finding bugs in this process, however. Other things that are different are optional dependencies. Python uses a very different system for optional dependencies than RPMs or Debian-based systems. So Python uses extras, which is extra dependencies that get added to the main one and enable a feature, while RPMs have a concept of weak dependencies, which you can just about abuse enough to support the extras with some automatic automatic subpackage generation. We don't really have the automation for this in place yet, but it looks like it will be possible with some changes in RPM build.
Another thing another thing that we often fight with is that the upstream distributors often pin their version of the dependencies, like in ranges or the maximum, minimum version and stuff like that. And in small environments, like Python virtual environments, it's usually not a big deal. But if we want to integrate it into the distro, where everything is installed all together, this is a real problem. So for example, if packaging requires PyParsing lower than 3, but a new version of matplotlib requires PyParsing at least in version 3, the package maintainers in Fedora really have to make tough choices. It's technically possible to package 2 different versions of PyParsing in Fedora, but users won't be able to have them installed at the same time. Often they would end up in some kind of dependency hell. So when we maintain the packages in Fedora, we need to do this very carefully, because our users expect the newest and greatest, but they also expect that it will work, it won't break. So we often end up driving efforts upstream to migrate something to a newer version of a dependency, or we add backwards compatibility to the dependency itself if it's needed. Another thing upstreams might do is that they vendor the dependencies, and usually this is not really looked at good in Fedora. It has its different kind of forms. You need to consider security and all the other things, all in the vendor dependencies as well.
Thanks. Another thing is licensing. The usual permissive license will say, you can use this software however you want it. You just need to keep this license with the software. And the fact that many packages still don't do this on PyPI, and the fact that the metadata for marking license files was only added, I think, 3 years ago, clearly as an afterthought, it's really it really shows that PyPI was built for developers, because the developers don't really care about licenses, but the users are the ones that will get sued if some evil corporation takes over the copyright. So we hope to fix this as well. Another thing is documentation. So Python packages have documentation on the web. Each project has their own tools and own processes how to build it. It's not standardized at all. And we try to build what we can in Fedora, but the documentation directory over there is really old and dusty and forgotten, and not as useful as it could be. Unfortunately, this is an area where there aren't enough people to drive many changes. Unlike tests, we are really interested in running tests for packages because we want to actually ensure that the stuff works. So in Fedora, we have the check section in a spec file, which hopefully would run the upstream test suite. And we have some extra checks in CI for integration testing and so on. PyPI packages or Python packages don't often even upload the tests to PyPI, so we need to use the original sources. And they also mix actual functional tests with linting, like are there the correct number of blank lines between functions, and is the indentation correct, and stuff like that. And those are the kinds of tests in quotes, that we don't care about, and those need specific versions of tools because they're basically suggestions rather than test failures. So we would rather not run them in any other environment than the upstream CI, which is specifically pinned. So we need to ask upstreams to separate these two kinds of tests so we can make sure that the stuff works without running the lints. And finally, there are descriptions. On PyPI, people just put the entire README file with all the instructions, all the licenses, the changelog, stuff like that. In Fedora, we just have a paragraph saying what the package does. If this was the only thing that the Fedora packager would have to add to the metadata, we would be very happy, and we hope to someday make it that way. But despite all these hardships and problems, we really love the new packaging ecosystem and the new way of having different tools that we can add to, and that enable us to fix bugs for everybody. We love the Python packaging platypus.
Thank you, Peter. I think that is a time for questions, if we have any.
Yeah, we have a bunch of questions. Thank you very much. And so our first question is, how long until we can just automatically provide any PyPI package upon user request in Fedora?
That you cannot do. Oh,
okay. I wanted to answer it because you talked so much. Anyway, I would say never, but not for technical reasons, but for policy reasons, legal reasons, and stuff like that. So a teammate from our team is currently working on a tool that could create all the code necessary, like, so you just give it a Python package name on the package index, and it will give you a functional RPM package. But there would still need to be somebody to take care of it in Fedora and take it under their wings. You can't just put random stuff in Fedora and it won't live there. It's not the package index. It's curated and maintained. Everything has a maintainer, and so this is the main blocker. But this is technically possible, and we will do it in the technical level, but it will never fly as an actual content.
So what we can do, and what we are planning to do, is to create an alternate index, which is not part of Fedora, so a copy repository that will contain all the PyPI packages that have a license and do build.
Cool, thank you. Next question. Have you encountered instances where metadata, for example, version constraints, cannot be losslessly converted?
Yes. But they are usually, I would say they are bugs that upstreams were not aware of because it accidentally worked. So, for example, recently we have found that you can require the name of the package is larger than def. And there is no standardized way to say what does that even mean, but pip handles it in some way that worked. So we can't really convert it unless we do a lot of guesswork and a lot of assumptions about how pip works.
Thank you. And then the next question was already answered on Element, but I'm going to ask here again. You have the PyPI distribution name as package metadata virtual name. Do you also expose import names in a similar fashion?
We don't. We thought about it, and it's technically possible. There's a big confusion. Even our Fedora packages are often confused by that the PyPI name, the dist name, and the importable module name is completely different and unrelated. And we decided we don't want packages to depend on the import names, because you can still have packages that have the same import names even though you need something else. But it is technically possible on RPM level to do this.
It is technically possible, and we actually extract the import names to run automatic checks. If the upstream test suite is missing, we at least try to import all the top level modules or all the modules. But yeah, this is a problem in the Python ecosystem, and it should be fixed there. And I don't really see how it can be fixed. So doing a Fedora specific solution for this doesn't seem right.
Cool. Thank you very much. And thanks again, Peter and Miro, for the presentation.